Hey, this is HansPerm. Today we're going to solve a 4x4 Rubik's Cube. And while I'm scrambling this, it would be recommended that you have already solved a 3x3, even it's a beginner's method or using a CFAB method. Okay. In a typical 4x4, we don't have a fixed center, so which means we'll be orienting our colors, which is we might be starting with the yellow and opposite will be the white. So now I'll be solving the first yellow center and then bring this up, and now it's already solved. Next would be the opposite, would be the white. I'll just bring this one already there and look for the pair of this one and align them so that we could wide slice and then bring it up there. So now we have already solved our two centers. So this time I'll just position my cube in this manner, so which means I'll be facing my yellow on the right so that we could perform a proper color orientation of a typical center of a 3x3. So let's say this is orange, green, red, and blue. So I'll start with the orange. Right now, solve green and align this one so that I could swap, and red, and automatically the last center will be solved. So this time all our centers are all solved, and we'll be moving on to a reduction method, which means we'll be performing now the edge pairing. So we can use this top as your buffer and even from the bottom, and all in all we have 12 edges to solve. So for now we'll see the first edge that you'll be working on. Say for example we could just pair off with the red, and this red will bring it down over here, and that one is the red, white, and bring it to the right, so that if I slice this one it will be now be paired. So which means the first edge will be solved and bring it up there as a buffer and replace it with unsolved edge. So we'll still be working on other edges, but this time we're seeing this green and white. So let me just bring this edge over here, and then we can slice and replace this solved edge with unsolved edge here. So slice it back. So this time I might be saying now a red and blue, but they are in a different case, which means they are on the same line. So in this case we'll be performing a swapping algorithm and then slice it back, and then there will be solved edge. Now we'll replace this one with an unsolved edge and continue on completing our first top buffer. And say you're seeing now this this yellow and blue, right? I can now bring this edge with the yellow blue because we're going to solve and pair that one, and this time we can now replace it with unsolved edge, right, and slice it back. So all of the top buffer is now filled in with solved edges, so I can now rotate this cube facing on the white at the top. So we can perform the same on filling up all this buffer by pairing up your edges. So I'm seeing this red and yellow. I can bring this unsolved edge because I want to pair this red and yellow and bring it up there and replace it with unsolved pair. Right, slice it back. So say for example we're having this green, orange, and this one. I can bring this one here on the left. But if you could slice it over there, it's already been paired, and replace it with unsolved edge. Now let's slice it back. Now we're quite lucky that our white and blue is already solved, so we can also replace it with unsolved edge, and basically we still have a couple of more buffer to fill in. Oh no, it's only one though. So which means we can just look for the pair of this one, and this green and red I can just place it over here so that it's an easy pair for this edge, and and replace it with unsolved pair. So this time it's recommended to bring it back on the proper center because we don't have any space anymore from the top and the bottom. So in case now, since we have 4 left edges unsolved, we might be bringing one unsolved edge on the top. That would be a gateway for our replacing unsolved edge. Right, so safe example, let's look for this orange and blue. Right, I'll just bring it over here and then slice it to the left, and of course we have to replace it with unsolved edge. There you go. Okay, slice it back, and basically we have only 2 left there. So there. So this time this case won't be working if you just slice like this. You will still be extracting all the solved edges there, but recommended from the last 2 edges they should be in the same line, right? So which means I have to do this one, a swap algorithm over here, and I can slice it twice though, so that I could do the swapping algorithm once again and slice it back twice, and all edges will be solved. So this time we are now on the 3x3 stage, which is typically you can now solve for a cross. So for now I'll be performing a white cross. Right, now this time for F2L. Okay, first pair. Okay, for second pair of F2L. Third one, and for the last F2L is this. Alright, so this time now we'll be moving on to OLL, but this kind of shape is not typical happening in your 3x3 Rubik's Cube. Why? Because of this flip edge. So this flip edge, we call this one as a edge parity when it comes to 4x4. So which means either it's OLL parity or edge parity. So we cannot perform the OLL without performing first the algorithm of the OLL or edge parity. Alright, so let me just perform this algorithm. Right, so once that the flip edge has been removed, now definitely you'll be seeing now the shape of your OLL. Right, so now this is a typical OLL. Right, so we're now moving into the last stage of which is the permutation of the last layer. So we will check if whether this kind of shape will be under your 21 PLL, and in case it won't be, there will be also a parity which we call the PLL parity in 4x4. But in this case, of course, this is a typical kind of a JPerm, right? So which means we don't have a PLL parity over here. So I can just perform a JPerm, and there you go. So let me just show you in case you might encounter a PLL parity. And it will be looks like this. So you can see that we need to permute these edges, and then we have to swap these edges, and normally this won't happen in the typical 3x3 cube. So which means this is an example of a PLL parity, right? So we can just perform that alg, and there you go. So this time we solve our 4x4. Thank you very much for watching. Have a nice day.